Okay, anywho, so our goal for this one, which is 20D, our intro to drawing covalent bonds, is to draw 3 covalent bonds. So by the end of the day, the goal is to draw these 3. And so this, sorry, give me a second. This is how we do that. So first things first, covalent bonding is sharing electrons between non-metals, atoms, and each atom has to have a full outer shell of valence electrons. These were kind of like the checks and the things we did yesterday. So this should sound a bit familiar, and you know they're between non-metals. We did that on Tuesday, and the electrons are shared. Okay, so these 5 steps are the steps that we use in order to draw these things. The first one is to count. So you add the number of valence electrons for each atom to get the total number of valence electrons for the compound. And that corresponds with the column that it is on in the periodic table. So basically we did this yesterday and all the days, many days. You like find your element, you find what column is in, that's how many valence electrons it has, and then you add them all up. Your step number 2 for drawing these is to identify the center atom. And the center atom is going to be the one with the most bonds. So if there's only 2 atoms in a covalent compound, then you're just drawing next to each other. But this is applying to if there's 3 or 4 or even 5 atoms. You have to figure out, okay, well, what goes in the middle? What is attached to what? How do I know this? And the way you do that is that the most bonded one, the one who has the most bonds, goes in the middle. And how you know that is this chart here, this table. So carbon and silicon, they get 4 bonds. So they'll always be in the middle. If there aren't those, but you have N's, P's, or AS, those get 3 bonds, so that might be in the middle. These 1-bonded guys, F, Cl, Br, I, and H, those will always be on the outsides because they can only make 1 bond. So that is that. My next one is step number 3. You will make single bonds between center atom and the other atoms. 1 single bond is 2 electrons. Step 4, and I'm going through these kind of quick because I'm going to go through more when I actually do an example. So step 4 is you add your remaining electrons, place electron lone pairs. So single bonds and lone pairs equal total valence electrons. And then check to make sure each atom satisfies the octet rule with 8 valence electrons. But remember, hydrogen only wants 2. It's our exception. He's the weird one. Hydrogen only wants 2. And then if an atom has fewer than 8 electrons, take a pair and then make a double or triple bond instead. So this will hopefully make sense a bit more after my example, and after you practice, it'll be better. So here we are. Follow along as I do it. This one I am really doing. I'm not going to ask you too many questions, but then the next one you'll do on your own, and I'll show your answers, and we'll go through all that. So, first things first, is I need to go to mine. So, we have our atoms. There's 2 fluorine atoms. And the first thing I ask is the atom type. The atom type will always be nonmetals because these are covalent bonds, and that is what covalent bonds are between our nonmetals. So, that's that. It will be that every time, but you need to get that in your head. That's why I have you type it every time. It is nonmetals every time. But like I said, yeah, you just need to get it in your head. Next is the number of valence electrons. So this is step number 1, count the valence electrons. So I have 2 fluorine atoms. I need to go to the periodic table and find F. So F is located here. If I count the columns, 1, 2, 3, 4, 5, 6, 7, fluorine is in the 7th column. So my number of valence electrons is going to be 7 for one of them. And then plus 7, because I have 2 of them. So this will be 14 total valence electrons. That was step 1. Step 2, identify the central atom by the number of bonds. Now, fluorine, I have just 2 fluorine atoms, so there's not going to be a central one. So I don't really need to do that. That step only applies if, that step really only applies if you have like 3 or 4 or more. 3 or 4 or more atoms. So what I do have though is 2F. So now I'm going to draw these down here, or type them. So I have F and I have another F. And I want them to be relatively close to each other, like so, but not too close, like just, just perfect, obviously. And then step 3 is drawing single bonds. So you just draw a single bond between whatever atoms you have in order to connect them, because that is how these things are bonded together. So I'm going to draw a line, make it as straight as you can. If it's not, that's all right too. So I have a single bond that is connecting my F's. That was step 3. Step 4 is add your lone pairs. Adding them in pairs is easier. So rather than single things, pairs I would recommend, but I'm not sure if it matters entirely or not. I just think it's easier. So, how do you add these? What are we doing? We need to have 14 electrons drawn. So I am adding pairs until I get to 14 drawn. Right now, I have 2, because remember, your single bonds represent 2 electrons. So I am going to add, oh, I don't want a line, I want a pencil. I am going to add electrons until I get to 14. I'm at 1, 2, so now I'm at 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, that was a little close. Oh well. And 13, 14. Remember, these are going on sides. This isn't like a flower and you put them all around. It's tops. They go on tops, bottoms, and then the lefts and the rights. That's our goal. Is it always perfect? No, but that's our goal. So now I added my lone pairs. I should have 14, and I have 14 drawn, so that's good. Step number 5 is to check my octet rule. So the octet rule, all of them want 8, except for hydrogen only wants 2 electrons. So I need to look at this. Now I'm going to draw this. You don't need to draw this, but it's nice to kind of see. So I'm going to circle all of the electrons that are surrounding this fluorine on the left. Notice I have 1, 2, 3, 4, 5, 6, and then the bond, so 7 and 8. So that is happy. Now I'm going to circle the fluorine on the right. Very carefully. And notice it has 1, 2 up top, 3, 4 on the right, 5, 6 on the bottom, and then 7, 8 from the single bond. So that single bond is shared because it goes to both of the F's, both sides. But so since the left fluorine has 8 and the right fluorine has 8, my octet rule is happy. It is satisfied. I'm going to undo my 2 circles. That's just to kind of show and see what is being applied to what. But this would be your final answer. This is good. This is done. It's all checked out. It's all great. My formula is F2. The name is fluorine gas. We'll get to the formulas later, and naming, we'll get to those later as well. Today, it's just drawing these guys. So I'll leave this up for a moment in case you are, actually I'm going to just look at you guys, see if you're all caught up. Most of us are very caught up. Okay, cool. I'll leave it up for like 10 more seconds. So if you're finishing, finish them quick. And then we're going on to the next example. Okay, I'm going to show your guys' responses, but you can keep like working on just making this clear. So our atom type is the first thing we wanted there. We have nonmetals, 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 nonmetal. Love that. Nonmetal, nonmetal. This one is still blank, but that's okay. I'm sure they're getting to it. Nonmetal. Okay, love this. So many of you guys too. That's great. Okay, so then the next thing that we're wanting to do is step number 1, which is count the valence electrons. So we have 1 hydrogen and 1 chlorine. Hydrogen is in the first column on this periodic table. So if I look, I find it, first column, so there's 1. Chlorine is in the 7th column, so there's 7. This person, awesome. 1 plus 7 gives me 8. So let's see. This person got a little ahead of themselves. They're drawing things already, but we still got to count our valence electrons. This one, awesome. We're there. We still need to count. Don't forget to count. People, I know you might be like, I'm getting there, but just know that part is very important. Okay, cool. So a lot of us have the 8. So then next, I've seen 2 O's at this point. We have hydrogen, which the symbol is an H, and we have chlorine, which the symbol is a Cl. So you aren't the only one. I think you might have saw somebody with an O, and then everybody was like O's. I don't know. But this person is going at it. Okay, cool. I'm gonna stop on this one. So we have our H and our Cl. Step number 2 is identify the central atom, but that does not apply because we only have 2 atoms in this case. So we don't need to worry about them. We just put them down. Step 3 is to draw our single bond. So we have H and Cl. We want to connect those. So you draw a line as straight as you can. I know it's hard. Between H and Cl to show the single bond. So let's see if this person is following along and does it. Come on. Or should I keep going and see what we got? Oh, cool. We'll go to this person's. Okay. So she has, or him, I don't know who this is, has the line drawn. Love that. Next is adding the lone pairs, which this person is doing. So we want to add enough electrons to add up to 8. So you need 2. That's how you know how many you're placing. So we have 1 and 2 from the bond in the middle. Then we have 3, because there's this one above hydrogen up here. And then 4, 5, 6, 7, 8, 9. Right now this person has 9 drawn, but we only want to have 8 drawn. So this person needs to erase 1. Let's see here. This person down here has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 drawn. You can only draw 8. You are only allowed to draw 8. Why only 8? Because that is the number of valence electrons that we get. Okay, so this person needs to delete 4 of those. Wait. Did I do that math right? I don't know. Maybe more. I don't remember how many I said you had and how many. That one's kind of small, but it's fine. Woo. Okay, cool. So we're getting there. I think I need to give you guys a sec to kind of catch up. Oh, yay, this person added a line, and it's so straight. Okay, cool. So I'm back to this person. Next is adding our lone pairs. So he drew this single bond. Now we need our lone pairs. This bond counts as 2 already. So I have 2 drawn. I need to draw 6 more in order to get to 8. So use your pencil tool to draw 6 electrons around this. Okay, and then I'm going to go to this person. So we have our 8 that are drawn. 1, 2, 3, 4, 5, 6, 7, 8. Love that. We need to check our octet rule. So everything wants 8 except hydrogen wants 2. So right now, if you're looking at yours and you look at your H, is there 2 electrons that are on it or surrounding it? 2 electrons can be attached to H. Right now, you have 3 because your H is attached to the bond, which is 2 electrons, and the one above it, which is 3. So that's 1 too many. And then we look at Cl, and we say, okay, Cl wants to have 8. It has 1, 2, 3, 4, 5 that are surrounding it, and then that single bond, so it has 5, 6, 7 electrons. So Cl wants to have 1 more. So this electron that's above H, you actually need to erase and move and put it onto Cl. So end of the day, this person has been finished for a while. End of the day, this one looks great. This is what your final answer should look like. We have H. It is connected to the single bond. The single bond is 2 electrons. So H has 2 electrons surrounding it, which is what it wants to be happy. And then Cl has 1, 2, 3, 4, 5, 6 of the pairs, and then 7 and 8 from the single bond. So that one has 8 surrounding it. So that is happy as well. Love this. This person fixed it. Perfect. Oh, and this person has the little circles, which is fun. Do notice on this one actually. And you don't need to change it if it's too hard, it's fine. But your element symbol should be capital and then lowercase. Capital and then lowercase. Love this. I just want to see if anybody is... This person still needs to figure out a little bit more, but that's okay. We're going to move on because we have 8 minutes left and we have one more we want to get through. So actually, let me check the comments section, our chat box really quick just to see if there's any questions. Okay, no, looks fine. Okay, so we're going to go on to our next one, our last one. Here you are, and I'm going to give you guys a moment. Tell me my atom type and then the number of the valence electrons. I'm going to keep the periodic table up in a moment. You need 1 hydrogen, 1 carbon, and 1 nitrogen. So I'm going to the periodic table. You need to find hydrogen, carbon, and nitrogen in order to figure out the number of valence electrons. Again. Okay, so we're getting going with that. Some of you have it, some of you don't. Don't get confused by this 6 in carbon. Some of you are like, oh, 6. No, it's the column that it's in is the number of valence electrons. So this is where it's 1, first column, second column, skip the columns, third, and then fourth. So this should be, for carbon, there's 4 valence electrons. And I'm going to show some of your answers just so we see. So non-metal, yes. And then 1 valence electron is in hydrogen, 4 is in carbon, and there's 5 in nitrogen, which gives us a total of 10. So don't skip to this yet because you don't know how many to place until you know how many you should have. Does that make sense for this person? So like you might have like 20 drawn here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 30. You have 14 drawn. And now you know, well, I can only draw 10. So now you gotta be like, oh, okay, great. And you gotta change some stuff around. So that's why we always count them first. So then we know how many we need to place. Okay, so then the next thing is identifying the central atom because we have H, we have C, and we have N here. So it's like, well, should C really go in the middle just because I listed it in that order? Maybe, maybe not. I'm going to show you. So pause on your screens a moment. And don't be too mad. But if I come back to here, this is how we know. So the element with the most number of bonds is the one that goes in the middle. So C, in this case, has 4 bonds. N has 3 bonds. H has 1 bond. So yes, C does go in the middle because it has the most bonds. So you will be needing to reference this. I mean, I'll have it on all my slides and everything, but just so you know. Okay, here we are. Now we're back. So it should be H and then C and the N. Oh, awesome. This person's doing great. They attached single bonds. They put single bonds in between each of them. So let me just see where we're at with everyone else. Cool. And this person's adding electrons already. Okay. This is getting a little nitpicky, but you do need to know it. If there is a bond on a side, you don't have pairs of electrons on the same side. So this pair can go on top or on bottom, but not left or right because like those bonds are already on that side. So just so you know. Cool. We're drawing our electrons in. We should have 10 total electrons. Oh, the purple person again. Love this. So we'll start with this one. So we have our single bonds drawn. They connected our atoms. Cool. Next is adding our lone pairs. So we already have 1, 2, 3, 4 electrons drawn, and then from the single bonds. And now she has, or he has 5, 6, 7. We need to get to 10. So we need to draw 3 more. 2, 2, and one more. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. And can I get a 10? I'm going to keep scrolling just to see if anybody's there yet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This person has 10. Love it. After you have them all added, so you have 10 drawn because you needed 10, you need to check your octet rule. So first one is H. This is the one I would start with. So H over here only wants 2. It's the weird guy. Right now, your H has 1, 2, 3, 4, 5. It needs to get rid of 3. And when you take these 3 away, you need to make sure you take them off of H and you put them onto the other ones. Because we still want to keep 10 total, but we just don't want them on H because H only wants 2. And it gets both of their 2 from the single bond. Cool. So you erase them. Now add those 3 somewhere else. Same with this person. You got to take them off H, put them on the other ones because H only wants 2 and they get it from the single bond. Okay, so this is checking our octet rule. Okay, I'm going to stay on this person. Love it. So then next, because we only have a few more minutes, next is checking our next octet rules. So C right now has 1, 2 from one single bond, 3, 4 from the other single bond, and then 5. So it wants to get to 8, not happy yet, but we want to see what N has. So N over here has 1, 2, 3, 4, 5, and then 6, 7. So N is not happy as well. They both want more. So whenever these things want more, what you need to do is share more. So you need to add a bond. This is where you make double or triple bonds from lone pair if needed. You need to add another bond between C and N and delete 2 electrons. So you erase one from, well, you erase 2. You erase 2 electrons, but you add another line between C and N. I love that this person is on it. I don't know who they are, but they are like following along. Okay, cool. Now we recount. C now has 1, 2, 3, 4, 5, 6. Still wants 2 more. N has 1, 2, 3, 4, 5, 6, 7, 8. N is chilling. N is happy. Okay. But C still wants more, so we need to share some more. So N, get rid of 2 more on N, because that's the only place where we have electrons left. And you are going to draw another bond, so a triple bond, so a third line between C and N. Oh, I spoke too soon. So we need to, because, let's see if they do it. We want to get rid of 2 electrons, 2 electrons from N, and draw a third, oh, yay, love it, and draw a third bond. So this is a triple bond, so a third line. There we go. And now count them. So H has its 2, love that. C has 1, 2, 3, 4, 5, 6, and then 7, 8 from the single bond from H. And then N has the triple bond, so that's 1, 2, 3, 4, 5, 6, and then the 2 above it, so that is 8. And that is your final answer. That's what it should look like. And I'm glad people, at least some people, were following along. Perfect, love it. Hopefully that makes sense. If there's questions, please ask. You don't have homework tonight. It was just doing all that.